16 Psyche might be one of the most unusual objects in the solar system, and there's a spacecraft on the way to investigate it further. This asteroid was discovered by Italian astronomer Annibale de Gasparis in the year 1852. He identified it using a visual telescope at the Naples Observatory in Italy. Psyche's orbit resides in the asteroid belt, which is between the orbits of Mars and Jupiter. Unlike some other asteroids whose orbits cross the Earth's, Psyche's does not, and so does not pose a threat to us. Its semi-major axis, or size of its orbit, is around 3 AU, and it has an orbital period of around 5 Earth years. It's too faint to be visible from Earth to the naked eye, but it should be visible through a mid-sized telescope in dark skies. In terms of Psyche's physical characteristics, it's one of the largest and most massive out of the over 1.3 million known asteroids. Its diameter is estimated to be around 220 kilometers across, which is around the distance from Vancouver, British Columbia to Tacoma, Washington. So compared to Earth, this really isn't that big of an object, and the fact that it's one of the larger ones says more about how tiny most asteroids are. In fact, Psyche's mass is around 2.3 times 10 to the 19 kilograms, which means it constitutes around 1% of the mass of the asteroid belt. If the mass of the asteroid belt were evenly distributed, we would expect this figure to be only 0.0001%. The asteroid belt's mass is highly concentrated into the top few largest objects. Let's now explore Psyche's composition. Astronomers use a system to identify different types of asteroids, called an asteroid spectral type. This has a similar motivation as the identification of stars, that both these objects tend to come with a predictable package of characteristics that can be ascertained by observing the spectrum of light that comes off of them. There are 3 main categories: C, S, and M types. C-type, or chondrite asteroids, are the most common and are made of clay and silicate rocks. S-types, or stony asteroids, are made mostly of silicate with some iron-nickel alloy. And M-type, or metallic asteroids, are made primarily of iron-nickel alloy. And this is the classification of Psyche. Something interesting, which is pervasive on internet headlines, is an estimation of Psyche's value, which is around $10 quintillion, thanks to all of its metal. Thus, it is sometimes thought that if we could somehow mine Psyche for this material, we will all become wealthy. 2 issues with this idea. Number 1 is that mining a distant asteroid is far easier said than done, and we have no way to realistically do this now, or in the foreseeable future. And number 2, the reality is that even if we could bring these metals back to Earth, the market for raw materials would saturate and crash, rendering these materials virtually worthless. Although at the time of writing, there are no close-up images of Psyche, data from ground telescopes has given us a pretty good idea of Psyche's shape. They're able to do this thanks to something called photometry. Psyche rotates on its axis every 4 hours, so telescopes can easily watch its light pattern as it rotates and build 3D models based on that. Additionally, Psyche sometimes passes in front of a background star, which allows astronomers to have an even better idea of its shape. These craters and valleys that you can see in this visualization are thought to exist based on these models built by said astronomers. How exactly an asteroid like Psyche originated is one of the big unanswered questions in our solar system. There are several hypotheses about its formation based on ground data, ranging from Psyche being the core of an ancient protoplanet, to Psyche experiencing ancient ferrovolcanism, which deposited lots of iron on its surface. But telescopes can only provide so many details. So if we want to know more about this asteroid to answer this question, we need to send a spacecraft to it. Luckily, NASA is already on it. On October 13th, 2023, said spacecraft, developed by NASA, launched on its way to the asteroid. This spacecraft has been given the same name as the asteroid, and it is thus referred to as the Psyche spacecraft. For our purposes, we will just refer to it as the spacecraft to avoid confusion with the asteroid. It is scheduled to arrive at Psyche in August 2029. As of the time of writing, it's currently on its way to the asteroid, but let's take a look at exactly how the spacecraft will get to the asteroid. In order for the spacecraft to fly from Earth to Psyche, it can't just fly directly there. This is because it would need to carry a very large amount of fuel with it for course corrections and to slow down, and this just isn't realistic. Instead, the Psyche spacecraft utilizes the concept of a gravity assist, where the spacecraft strategically flies by a planet to adjust its trajectory and speed. In particular, this was a flyby of planet Mars, which successfully occurred on May 15th, 2026, passing the surface at a distance of around 5,000 kilometers. In addition to adjusting its trajectory, the spacecraft used this flyby as an opportunity to calibrate its instruments and test out its camera again. In practice, this seems like free energy, although of course, we all know that free energy doesn't exist. In reality, the spacecraft exchanged a tiny amount of energy with Mars, so the energy is conserved. Regardless of the physics, it's a critical strategy to make the mission viable in the first place. The spacecraft is scheduled to arrive at Psyche in August 2029, where it will begin a science phase of at least 21 months, where it will study Psyche in detail. Over the course of the science phase, it will orbit in 4 different configurations called regimes, allowing it to fulfill different mission objectives. These orbital regimes, in chronological order, are called Orbit A, Orbit B1, Orbit D, Orbit C, and Orbit B2. Originally, these were supposed to be in alphabetical order, given that the mission was supposed to launch in 2022. However, the delay forced this adjustment to be made to ensure the correct illumination of the sun during the science phase. Orbit A will be the regime upon arrival, beginning in August 2029 and lasting for 56 days, the shortest of the 4. Recall that the scientists are unsure about how exactly Psyche formed, and that knowing the characteristics of its magnetic field would provide critical clues. So one of the 2 main goals of Orbit A will be to try and characterize Psyche's magnetic field, if it has one. The other main goal of this orbit is to map out the asteroid, giving us the first high-resolution look of Psyche we've ever had. Being the arrival orbit, it'll be the highest one, at an altitude of 700 kilometers and a period of 33 hours. The next orbital regime is Orbit B1, or the first segment of Orbit B, beginning on October 2029 and lasting 92 days. This will be closer than Orbit A, having an altitude of 303 kilometers and a period of 12 hours. The main goals here are to continue to characterize Psyche's magnetic field and to study Psyche's topography. This will provide us with even higher resolution images and data of Psyche's surface than orbit A. The third orbital regime will be orbit D, the closest one, and originally meant to be the last regime. It'll be at an altitude of just 75 kilometers from the surface, with an orbital period of just 3.6 hours. Using its onboard multispectral imaging instrument, the spacecraft will take extremely detailed observations of Psyche's surface and study its composition. Finally, the spacecraft will jump back out to orbit B for a second time, this regime being B2. It will have the exact same objectives as orbit B1, being to characterize Psyche's magnetic field and study its topography. Psyche is simply a fascinating asteroid, and it's quite exciting that there's a spacecraft on the way to get a closer look at it. I personally cannot wait to see some of the images the spacecraft will send back. Being 4.5 billion years old, studying Psyche will give us a picture of the early solar system unlike anything we've had so far. I hope you, who has reached the end of this video, are fascinated too.